Hello, everyone. Today, I'm going to be talking about error. So why does error matter? Well, GIS impacts society, so all the errors we make are going to impact society as well. GIS has influence over decision-making, policy analysis, knowledge generation, just to name a few things. And so if we create errors in GIS, those errors are going to be reflected in the decisions and the policies and the knowledge. So I'm going to post a couple of videos today just talking about error, different sources of it, some of the impacts of it, some of the ethical ramifications. I'm also posting a video explaining a geocoding tool that I've created, just that's something that might help you in your final projects. So that's not actually part of lecture. If you're not going to do any geocoding, you don't necessarily need to watch that video, although it might be helpful. So to start off, just going to talk about error and uncertainty. So there's a couple different types of error. At least in regards to GIS, we can have positional errors. So that's errors with the location of something. Attribute errors, so that's errors with the actual data that's associated with that location. Conceptual and logical errors are kind of related. So conceptual errors are regarding our framework for thinking about something, and logical errors are in our execution. Regarding positional and attribute errors, we can have uncertainty that's associated with the measurement of the positions or attributes. And so with that, we have two closely related but distinct things that we need to talk about: accuracy and precision. Accuracy is the degree to which a set of measurements correctly matches the real world values, whereas precision is the degree of agreement between multiple measurements. So if you repeat it multiple times, how close are they together? So in the top left on this diagram, you see low accuracy, low precision, where the values aren't really close to the measurement and they're pretty dispersed. On the top right, you see low accuracy, but high precision. So it's not accurate, it's not close to the real world value, but they're all clustered very close together, so it's precise. Bottom left, you see high accuracy and low precision. So they're all fairly close to the real value, but they're fairly dispersed from each other. And then high accuracy, high precision, everything is both close to the real value and close to each other. So accuracy, again, is how close something is to a real value, and precision deals with repeatability. If you repeat it multiple times, how close are all the measurements going to be to each other? So accuracy, how close are we to the real world? If there's a consistent offset from some real world value, then that measurement is going to be inaccurate and it's going to be said to have a bias. Precision is how repeatable is the measurement. So if you take 5 measurements of the same feature, how likely are they to all be similar? Additionally, we also have vagueness and ambiguity. So vagueness is something that's not clearly stated or expressed. Vagueness can arise when the meaning of something isn't explicit or the referenced object is not distinct. So some examples might be boundaries that aren't clearly defined, data might be collected from an estimate, or the positions of objects are unclear or changeable. Ambiguity is uncertainty in the meaning of something. So ambiguity arises when you could be referring to several possible things. So labels often apply to multiple features. For instance, does London refer to London, UK or London, Ontario? If you type London into the geocoder, it's going to send you to London, UK. But if you type London, Ontario, Canada, then you'll get sent to London, Canada. So additionally, multiple points of interest might be located near a label on a map. Which one does it refer to? So in the context of GIS, for our purposes, you can consider uncertainty to describe all problems that arise from our imperfect understanding of the world, our inability to measure anything exactly, and our imperfect nature when translating the real world into a GIS. So error and uncertainty is unavoidable. And to quantify it, you can think of this little equation: uncertainty is equal to error, so that's like your precision, plus any inaccuracy, plus any ambiguity, plus any vagueness, plus any possible misunderstandings, which I'll talk about in a little bit, so logical flaws in the data and your conceptualization of it.